So ladies and gentlemen, on harnessing the power of zero knowledge, please put your hands together for Anthony DiPrinzio and Nse Barna.
I want to say thanks for having us today. We're really excited to be here. This is actually both of our first time in Barcelona. Amazing city. Definitely want to come back at some point. And yeah, today we're going to be talking about harnessing the power of zero knowledge proofs and how you can actually start building using zero knowledge via a project that we work at called Aleo. Awesome. So yeah, just to give a quick introduction on both of ourselves. So I'm Anthony DiPrinzio. I'm head of growth at Aleo. So mainly what I focus on is working with developers that want to build on our platform, also looking for different partnership opportunities for folks that want to get involved in the ecosystem. I've been at the project for 2 years, and I've worked in crypto at various companies since 2016, and this has actually honestly been the most fascinating project for me to work on, and yeah, really excited to share with you what we're doing. And Nse?
And I'm Nse Barna, and I'm the chief of staff, and for me at Aleo, I just have this bird's eye view on the operations and a lot of the innovative projects that we're doing. This is my first time in this space, and like Anthony said, I've been here for 2 years as well, and like Anthony said, it's been an amazing opportunity and an organization to be a part of. So I'll start, and much like many of our own journeys, Aleo traverses into the realm of the blockchain space. There really is something inherent about the exploration and the constant learning that we're doing here at Aleo. One of the things that it's important to note throughout this presentation is that Aleo is not an Ethereum or Bitcoin or any other blockchain killer. Aleo is a stride forward along an established path, acknowledging the many efforts and projects that came before it. In the field of cryptography, it's built off of many past attempts to create digital money. And although many projects failed, they did pave the way for things like Bitcoin. And with Bitcoin, which is a groundbreaking innovation, it wasn't cryptographic, but more crypto-economic. The idea was that if you align incentives correctly in a network, say between like miners and other participants, which Anthony will get into later on, the system can be trustless and permissionless. Ethereum took another step forward. Vitalik acknowledges many times that the potential for Bitcoin, but thought that it could be way more powerful, not just currency on the blockchain. This led to the concept of an on-chain virtual machine, and it opened up a whole new direction in the world of blockchain. And then Aleo continues this tradition. Based on a 2018 research paper called Zexy, the idea was to blend elements from previous approaches, accepting some trade-offs and enabling computation of programs transitions off-chain while verification happens on-chain. In Ethereum's model, where every transition needs to be validated by each node in the network, this setup requires something called gas. You want to hit the next one? To keep the system from overloading. Aleo removes that need by executing computations off-chain, which leads to a key advantage that we think, which is the unlimited program runtime. If the way that works is if you imagine you're trying to solve like a complex problem like sequencing the human genome or predicting weather patterns, this can take years to complete. In Ethereum, you would hit a wall because of the inherent complexity limits. On Aleo, you can run an algorithm like the genome sequencing off-chain for many years, and once you get the result, you can present it as a proof, and it's valid just like any other proof is valid. And then you can think of Aleo as like a holy matrimony between smart contracts and zero-knowledge proofs, or if Ethereum and Zcash, had a baby, they have Aleo, especially architecturally. The one thing that I will note is that it is possible to have 100% zero gas fees if you decide to do all of the applications off-chain, but if you choose to have like a shared state or have part of the computation on-chain, that there will be a gas fee.
Cool, yeah, and I guess one other thing I just want to mention here, because we didn't really bring it up, like how many people are familiar with zero knowledge? Just raise of hands. Okay, so it seems like at least more than half the room is familiar. Main thing we're trying to do here is leverage zero knowledge for its privacy preserving properties, which if you go all the way back is what zero knowledge was originally designed for in the 1980s, right? Like a lot of people have been using zero knowledge for the context of like scaling other layer ones in you know, through like roll-ups or other kinds of solutions. Our solution effectively does everything that a rollup does out of the box, but again, our main focus is how can we actually take the privacy preserving properties of zero knowledge and enable developers to start building decentralized applications with ZK. And I'll start talking a little bit about that, but I just wanted to make sure everybody kind of understood the importance of the zero knowledge component. So now that Nse gave that amazing overview, what I wanted to do is just dive quickly into how you can actually start using zero knowledge on Aleo. And the first thing I want to talk about are the three main actors that are involved in the ecosystem. So the main actors here are developers. So these are people that write and deploy applications on our network. Then you have provers. These are individuals that actually run those programs by generating zero knowledge proofs off chain, like Nse was talking about. And they do this using specialized hardware that they create, and I'll talk a little bit about that later. And then we have validators. So validators, these are the individuals that actually contribute to consensus on Aleo's network. So what they do is they take the zero knowledge proofs that were generated by the provers, they verify them that they're accurate, and then they append them to the blockchain, which obviously is a global ledger that everybody can see. And so each of these actors actually interacts with our various parts of our stack. So if we go from right to left, the developers, the way they're able to do this is actually by using our ZK domain-specific language and compiler. It's called Aleo. It's designed very similarly to languages like TypeScript or Rust. So if you're a web developer, learning Aleo is actually pretty easy. In fact, we'll be doing a workshop on Saturday. Neither of us come from a traditional engineering background, but yet we've learned how to use Aleo and actually have built applications on Aleo using ZK. And then for the provers, they actually operate on our virtual machine called Snark VM. For those that aren't familiar, the term Snark is a specific flavor of zero knowledge. It stands for succinct, non-interactive arguments of knowledge. We get into a whole debate about Snarks versus Starks versus all these different flavors, but this is the one that we use. And so our virtual machine is not a ZK EVM. It's just a ZK VM. We've developed our own zero knowledge virtual machine from the ground up that's designed for privacy because, as Nse was mentioning, you know, on other platforms like Ethereum, you can't do privacy, right? Like the Ethereum virtual machine inherently doesn't support certain opcodes that enable privacy. That's not to say Ethereum's not a great platform. I love Ethereum. I came from that ecosystem. It's just there might be particular use cases where you want privacy, and Aleo could potentially fit that for you. So that's where the provers are interacting. And then the validators, they actually interact via our operating system, which is Snark OS. And if you remember from a couple slides ago, that zero knowledge execution concept that Nse had mentioned, this is all happening between Snark OS and Snark VM. So basically our founders, they actually published a paper back in 2018 on how you can actually generate these zero knowledge proofs in a trustless environment off-chain. And that's sort of the core innovation behind Aleo. And one thing I just want to clarify, because people always ask, the provers do not contribute to consensus. Only the validators do. The provers are just there to generate the zero knowledge proofs in our system, and we actually have a mechanism that incentivizes them to do so, but it is not related to consensus. That is all within the validators. And the consensus mechanism for the validators is something called Aleo BFT. It's the same consensus mechanism that Aptos uses, so Bullshark and Narwhal, if you're familiar. And we're currently implementing that right now. And so this is just another way to sort of visualize the different actors in our ecosystem if you're familiar with Ethereum. So the one-to-one here is like, okay, developers on Aleo, similar to developers on Ethereum. On Ethereum, you have people writing smart contracts which people can then interact with. On Aleo, we also have developers there in our system. We call them programs. They'd be writing a program which actually gets deployed to an on-chain program registry, which I'll talk about a bit further, and which people can interact with. Then you have the provers. So these are the people that are generating the zero-knowledge proofs in our system. In Ethereum, the way they're using zero-knowledge proofs is in the context of scaling solutions like rollups. So fundamentally using it for a different purpose, but that's sort of where the zero-knowledge is coming in across both platforms. And then obviously, well, Ethereum doesn't use as miners anymore, but validators, and then we also have validators. So same kind of idea here, right? Like the validators on Ethereum are coming to consensus about the chain, same thing on Aleo. And then one thing I wanted to talk about here is that, and at least for me, this is one of the more interesting things, is with our programming language, essentially what's happening is you can take this complex cryptographic and mathematical proof generation and convert it into something that your computer can reason about, which is really cool, right? And this is what enables developers to actually start building with zero knowledge, which when we launched Deploy and Execute a few months ago was actually the first time that the concept of Zexy actually came to reality. We were one of the first projects to do that, and I just think it's a really cool concept. And just at a high level, like if you're curious, what happens is you write your program in Leo, it compiles to an intermediate representation called Aleo instructions, which is more assembly-like, and then that actually gets compiled to bytecode, specifically R1CS. So yeah, and the example I put here is like, something very basic is maybe I want to prove I know the sum of two numbers. You could have a public and private variable and some private output, and we can basically validate that the output is correct without having to reveal one or both of the inputs, just depending on the specific use case. And then just briefly going through the steps of like how you can actually do this Aleo. So like I mentioned before, you can deploy your program, right? Essentially what you do is you write in Leo, and then it gets deployed to an on-chain program registry. Now, I want to highlight the on-chain program registry because I think it's a really interesting and novel idea. So basically, our on-chain program registry is effectively a namespace. So if you go to any block explorer on Aleo, you can actually look at every program that's been deployed and see what people have written. And the reason that we need to have this program registry is because transactions on Aleo are private, you need to know what program they're actually interacting with, and so you can reference those programs on this on-chain program registry. And it's also a great way to facilitate like composability on Aleo. So anything that somebody wrote in one program, you could actually take and use in your own program, which is really important. And then actually one other thing I want to say about this is that Aleo is a private by default platform as well. So people always ask like, okay, you have all these private programs and transactions going on, like how do you meet regulatory compliance? How do you prevent like, nefarious activity, things like that? Well, because we're private by default, what it means is that when I write a program on Aleo, by default, everything is private. But then you as an application developer have the optionality to decide what information you want public, what information you want private. Maybe you write a certain program such that if certain actions take place, then you could selectively reveal certain information. And then on the end of the user, you can also decide what you want to selectively reveal. So for example, maybe I need to verify my identity to some authority, and they need to specifically know my exact birthday for some reason. I can selectively reveal that if needed, or based on the program that's used for that specific application, maybe that information is public up front. It just depends on whatever regulation you're trying to follow and the specific use case. But I think that's a really important thing to highlight. And the piece where you can actually review your information is done through something called a view key. So yeah. And then, okay, cool. So you deploy your program on chain. Then the next thing is you execute your program off chain. Again, you can do on-chain computation, and you can have on-chain computation in shared state if you want. We just have to remember in that case there would be a concept of gas because we have to prevent somebody from doing a denial of service attack, obviously. But anything you do off chain, there's no gas fees involved. And what happens is these provers will actually generate zero-knowledge proofs and run those programs. And you might think to yourself, okay, how does that work and why are they incentivized to do so? Well, we have a mechanism called proof of succinct work. It's a combination of traditional proof of work and a paper called proof of necessary work. I don't have a ton of time to go into the whole thing, but basically the high-level idea is that all of the computation used is actually necessary, right? So maybe people have heard about proof of work being very wasteful for the environment. In this case, you're not necessarily reducing the amount of electricity spent, but at least it's all being used for something and not just wasted. However, over time, we want to try to reduce the complexity with which it takes to actually generate zero-knowledge proofs and the cost. And so through this mechanism, we actually incentivize these provers to create more efficient hardware for generating zero-knowledge proofs, because essentially they have to compete with each other to generate the proofs on the network and solve a coin-based puzzle that we have embedded. So if you're familiar with Bitcoin, right, in Bitcoin you grind SHA-256, right, and then you basically get like a block reward if you mine a block. In this case, what you're doing is you're solving a coin-based puzzle at a set difficulty target, and then you receive a pro rata share of the rewards from that. So depending on how much computation you submitted to solve that coin-based puzzle, you'll receive a pro rata share. And when you're solving that coin-based puzzle, you're not generating a full zero-knowledge proof, you're just generating something called a polynomial commitment scheme. Again, it's just there to make sure people are constantly running their hardware and like competing. But then again, if you actually want to generate a full-blown zero-knowledge proof for an application, that's a separate thing which you can do. And if you don't have the requisite hardware to do so, you can outsource it to a prover. So this is something we call proofs as a service, right? So maybe I'm just an end user that needs a proof generated. I go to a marketplace, I pay a fee for them to generate the proof for me, and then I can start using it in my application. And those transaction fees will be determined by supply and demand on a market. And then the last piece is, okay, so once the prover has run the computation and generated zero-knowledge proof, the validators will verify that those proofs are accurate, come to consensus, and then add it to the chain. And now you'll basically just have this chain with a bunch of zero-knowledge proofs that represent some transactions that occurred. But again, you don't know all the underlying data behind those transactions, right? You just have the proof, which is a statement saying that, like, okay, this piece of information I'm trying to claim is accurate. So that's kind of where you're getting the privacy aspect.
Oh, okay. So, by leveraging zero-knowledge proof, like the DeFi and lending protocol on something like Aleo ensures privacy for participants while enabling efficient borrowing and lending securely and trustlessly. If you think of like stablecoin protocol that prioritizes privacy, if you like a stablecoin pegged to like a fiat currency can be created where users can mint, transfer, and redeem stablecoins privately using zero-knowledge proofs. This ensures transaction amounts, user balances, and the underlying fiat reserves remain confidential. Some of the other use cases would be something similar, like what Anthony mentions, like identity verification, like KYC, or the voting system. The implementation of zero-knowledge machine learning by preserving data privacy and securing outsourcing, or even like ZK gaming, which allows for the delivery of provable fair gameplay, enhancing security, all while protecting a user's privacy.
And personally, I'm really into the machine learning example. I think there's a ton of interesting use cases about that, so if you want to talk about it later, let me know. Cool, so that's what we had for our presentation today. So if anybody's interested in getting involved in Aleo, there's a few different ways that you can right now. So we do have a developer grants program going on. So this is for people that want to build applications on our network. You can receive funding to do so. We also have a bug bounty program for our operating system and our virtual machine. So if you're a white hat hacker or security researcher that's into this kind of stuff, we have a program on HackerOne and BugCrowd. If you go to our blog, you can find updates on all of this, but we have the information on how you can submit to that as well as the grants program. And then right now we have incentives on our deploy incentives on our testnet, and that's going till July 15th. So I guess you have about like a week left. And basically we're incentivizing people with testnet Aleo credits for anybody that deploys a program. You can almost kind of think about it like a hackathon. So once everybody deploys their programs, we'll have like a review committee and we'll award prizes. One thing I want to say is that if you don't think you're going to fall in the top submissions, don't think about it that way. It's a cool way to just experiment with Leo and get involved in the ecosystem. And if you build something cool, even if you don't win, we will find a way for you to continue your work on the project. So I would definitely highly encourage it. And again, go to our blog for this information. Here's some additional resources. We're actually relaunching our website in August, so all the stuff will look a lot more beautiful on the website, but I guess if you just want to take a picture of this, this repo, Awesome Aleo, on one of our co-founders' GitHub profiles is really good. There's a lot of examples that people have built on Aleo. I highly recommend checking it out, and if you're interested in running a node or anything like that, if you go to the Aleo HQ GitHub page and go to the SnarkOS repository, you can find details on that. So yeah, with that, thank you, and we really appreciate you having us today. Thanks so much.
Yeah, can we get a microphone for a question? Just Joaquin down here with the pink dress.
Hi, thank you. It sounds like new, fresh spirit of decentralization. And how are you going to struggle against regulations? Because if you don't have KYC and etc., you know.
Mm-hmm. Yeah. So this goes back to the fact that our project is private by default. So basically what that means is, for example, I'll just give a practical example. Like I was in Korea recently, and in Korea, they have their own mobile applications that you have to use. And that's because they have like privacy and security concerns, obviously threats from North Korea, and just as a country, they're much more conservative. What I said to them is, well, we can actually develop an application specific for that region, right? So basically you can go to the on-chain program registry. Maybe we see that somebody who's using it is like Korean or something like that, then they would have to use that program which we built. And so what that means is, like, as an application developer, I can decide what information is public, what information is private. Like, if needed, like, we could potentially give access to a regulatory body for specific aspects of the program if needed, like if certain actions are taken. So basically whatever the regulation ends up being, we can follow it. We don't know exactly what it's going to be because it hasn't been fully established yet, but whatever it is, Aleo can definitely follow those guidelines. The bigger question is, are the regulations going to be so tight that what we're building doesn't even make sense in terms of like applications deployed, or is there going to be like a happy medium? And honestly, in Korea, people were actually kind of interested in this specific case, because what we can argue is that they can still have access to their citizens' information, right? But no outside threats would be able to have access to the information, because let's say North Korea did breach it, all they would see are a bunch of zero-knowledge proofs that don't actually give them data, which they could use incorrectly. But we could still, create some way for the South Korean government to have access if needed. So yeah, that's what I'd say. And we are building a KYC AML product right now using Aleo, so specifically to answer that part.
Oh, there's a question on the screen here if you want to take that as well. Just.
What is your energy consumption when compared to proof of work and proof of stake? That's actually a pretty good question. I mean, right now we're in a testnet, so I guess, yeah, the numbers aren't like 100% maybe accurate of what it would look like at mainnet. We're still implementing our consensus mechanism, so I don't have any hard numbers on that. In terms of the proof of succinct work part, I can't remember off the top of my head, but if you go to our blog post, there's actually a piece on when we incentivize provers to run during our testnet. If you look at that, there's like some very specific metrics about what the output was of that. I think proofs generated, yeah, there was definitely like over 1 million or something like that. But yeah, for the exact number, I would check that blog post.
Anthony and Nse, everybody.
Thank you.